In this video, we're looking at finding the equations of lines. Now, if you have a few things, you should be able to find the unique line that satisfies those things. For example, if you just have a point here, and you happen to know what the slope of the line is going through the point, well, if you think about it, there's only one line that does that, because I just drew that line. It goes through that point and it has that slope. Another situation you could be in is if you have 2 points, let's say here and here, there's only one unique line which connects those 2 points in a straight line. There it is. So you can either be given a point and a slope, or you can be given 2 points, but either way we should be able to find the equation of the line which does that thing we're looking for. So we're going to do slope and a point first because it is easier. We're going to find the equation of a line passing through 1, 3 with a slope of 4. So we'll draw that point on our graph straight away, 1, 3. And then we're going to think about this slope. So basically, if I lock in the slope, no matter what that slope is, you can see there's only one unique line that satisfies it goes through that point. But I want the slope to be 4, so it's going to look something like that. But we'll find this algebraically first, and then we'll see if we get it right when we graph it. So basically what you do is you follow these steps. So we want to write out the equation as y equals mx plus c first, just like that. Now, knowing that m is the slope of the line, and we already have the slope of the line, I'm just going to replace that slope with 4 because we already know it's 4. That's all that I've done there. So we've done step 1. Now, step 2 is to substitute in our point to the equation and work out what it is. So basically, I'm going to sub in this 1 for our x value and this 3 for our y value. And as we learnt last time, if the point lies on the line, then when you sub it into the equation, the left-hand side and the right-hand side should both equal each other. So let's try that out. Y will now become 3 and x will now become 1. But apart from that, all the rest of the equation stays exactly the same. That becomes 4 times 1 because that means 4 times x when you write it like that. Now let's see what we get. 3 equals 4 times 1 plus c, so that's a fancy way of saying 3 equals 4 plus c. And then if I want to rearrange this for c, I can take away 4 from both sides and see what I get. 3 take 4 should give me minus 1 equals c. So that's now told us what our y-intercept is. So if you want to put that all together, our original equation was y equals mx plus c. But now we actually know what m and c are. M was 4 because that's the slope, and c was minus 1. So that becomes y equals 4x take 1, and we've successfully done the question, which is great news. So in theory, our y-intercept should have been minus 1, and then if I draw the ruler up here, when I join those together, I should end up getting a slope of 4. Chuck arrows on the end of it. Y equals 4x take 1. So this kind of question is often done just with algebra, and you don't need to draw a picture all the time, but drawing a picture can help. So there we go, unique line passes through that point, has a slope of 4. Now let's do the version where you get 2 points. I'm going to get the point 3, 4 and 6, 0. So here's 3, 1, 2, 3, 4. Here's 4, 5, 6, just there. So we've got a point at 3, 4, and we've got a point at 6 in the x, 0 in the y. And in theory, when I join these two dots up, that should give me a unique line that goes through them both. Something probably looking a bit like that, but we'll see how we go with the algebra. So basically what you need to do here is just one extra step at the start, and that's to find the slope between these points. You might remember a slope formula from a couple of lessons ago. It looks like this. There we go. And the way we work with this formula is we label the point as follows. The first point gets x1 and y1, and the second point gets x2 and y2. And as long as you get them the right way around, nothing will go wrong. So on the top we got y2 take y1, that is 0 take 4. And on the bottom, x2 take x1, that's 6 take 3. Good stuff. Okay, so, well, our slope is going to be minus 4 over 3. Interesting stuff. So, there's a slope. It's a fraction, but it works. So in theory, and this kind of works out, if I go down 4 squares, I should go across 3 squares, which it looks like has happened on this graph already, just with the way we've drawn it. Excellent. So now we actually have to go through the whole process that we did before, now that we know what the slope is. So our graph was supposed to be y equals mx plus c. And we already know what our slope is, y equals minus 4 over 3 x plus c. Now all you need to do is substitute in any point. So maybe I'll pick the point 6, 0 to sub in. So y will become 0 and x will become 6. Minus 4/3 times by 6 plus whatever c is. Now 4/3 times 6 might be something tricky to do, but that's why we have calculators. So we'll have a look and see what it spits out. Minus 4/3 times by 6 should give us minus 8. That becomes 0 equals minus 8 plus c. All you have to do is add 8 to both sides now, and you're going to get c equals 8. So I think that should be roughly what we wrote there. So that should be a y-intercept of 8. And to do our final answer, this line is going to be y equals minus 4/3 x plus 8. There we go. That's the equation.